Okay? Any questions on the first derivative? Okay, I did a product rule here. So I have the first, okay, times the derivative of the second, plus the second times the derivative of the first, minus the derivative of that, equals 0. Get y prime all by itself. Okay? So hold tight 1 second. Here's what's, not that this is what's not to do, but this is an example that's going to be, don't write this down, because there's going to be an easier way. So there's my first derivative. And to find my second derivative, I would then just y double prime equals, and I'd apply the quotient rule. So I have the bottom times the derivative of the top. Now, the derivative of the top, the derivative of 1 is 0. The derivative of this requires the product rule. So I have the first, which is negative x, times the derivative of the second, which is 2y prime, plus the second, y squared, times the derivative of the first, negative 1. So that's my bottom times the derivative of the top, minus the top times the derivative of the bottom. The derivative of the bottom requires the product rule. First times derivative of the second, plus the second times derivative of the first, all over bottom squared. So that's going to be x to the 4th y squared. Not pretty, right? Not only that, but what I'm going to clean this up, when we give a second derivative, it cannot be in terms of the first derivative. So on top of having to clean this up, I'm also going to have to, well, let me clean it just a little bit first and I'll talk about it, but I've got to distribute this. So x squared y times negative 2xy prime is going to be negative 2 x cubed y squared y prime. That's just the first term. When I distribute here to negative y squared, I'm going to get y, or minus x squared y cubed. Here, I really have to FOIL. Yes? Binomial times a binomial. I'm going to keep my minus out in front. And then that's just going to be x squared y prime plus 2xy minus x cubed y squared y prime minus 2x squared y cubed all over x to the 4th y squared. So it's pretty well simplified. I still have to distribute my negative sign to these 4 terms, which I will do. But like I said, the second derivative is not written in terms of the first derivative. It has to be written in terms of x and y only. So this I need to lose. And this I need to lose.
And I'm going to lose it by substituting this, because that is the first derivative, back in for this. Did I make a mistake?
You missed the last time.
Where?
Well, it's on the sheet.
Oh. Tough crowd. So I would then substitute in this fraction, yeah, real ugly. Okay? And that's because when I go to derive this one, it's the quotient rule with two product rules within it, which is just gross. So we have to start to try to find cleaner ways of deriving. So if I can avoid the quotient rule with two product rules inside of it, I want to do that. So I'm going to rewrite this as 1 minus xy squared times x to the negative second, y to the negative first. So I just brought that denominator up into the numerator. And I still don't want to do the product rule within the product rule. So I'm going to distribute this, and I get x to the negative second, y to the negative first, minus, what's going to happen when I multiply x to the negative second times x? Very good. And the y to the negative first times the y squared. Just y. So this is going to be my y prime. And this is what I'm going to take the second derivative of. Still not going to be the most beautiful thing in the world, but it's going to be a heck of a lot nicer than that other one looked. So when I jump into y double prime, on this first term, I need to do the product rule, yes? Yeah, right. Yep. For the first derivative option?
Yeah.
Probably not. If it was just find the first derivative, they're going to leave it as a cleaned up fraction. But I'm saying now, since we have to go further with it, it's going to be easier to do that. But I would guess that any multiple choice would be left, because this technically is not simplest form. Negative exponents really shouldn't be in final answers. So they would leave it like this. But we're taking it beyond that, and this is going to help us make that a little bit cleaner. So our product rule here is our first times the derivative of the second, which is negative y to the negative second, y prime, plus the second, y to the negative first, times the derivative of the first, negative 2x to the negative third. So that's just the first product rule. If we want good organization, I'm going to do that. Minus, on the second one, I'm also applying the product rule. The first, x to the negative first, times the derivative of y, which is just y prime, plus the second, times the derivative of the first, which would be negative x to the negative second. So when it comes time to clean up here, I'm going to sort of do a couple things at once. I'm going to substitute out this y prime, so I'm keeping it x to the negative second. Oh, there's a negative on there too. This negative in front of the y. So negative x to the negative second, y to the negative second, and I'm taking out the y prime and replacing it with x to the negative second, y to the negative first. Minus x to the negative first, y. And then this next term is just a minus 2x to the negative third, y to the negative first. Then I'm going to distribute this minus sign. So it's going to be minus x to the negative first. And I'm going to replace the y prime with this again. And then when I distribute this here, it's going to become plus x to the negative second y. It's getting better. I know you don't see it, but it is. So now I do have a couple binomials that I need to distribute to. So when I distribute here, I'm going to get negative, what's the x raised to? Just this first term. Negative 4. And y to the negative third. When I distribute here, it's going to be plus, what's my x raised to? Negative third. And what's my y raised to? Negative first, good. I'm going to leave this alone. Oops, sorry. I'm going to leave that next term alone. I'm going to distribute the negative x to the negative first, which is going to give me negative x to the negative third, y to the negative first. And then a positive x to the negative second y plus x to the negative second y. Okay. Ugh. Combining like terms. See any? Where? These three here. And these two here. So the first term is negative x to the negative fourth, y to the negative third. I have 1 minus 2 minus another 1, which would be negative 2 of those. And then I have 2 of these. And then within each term, we're just getting rid of the negative exponents. So this one would be negative 1 over x to the fourth, y cubed. This one's going to be negative 2 over x cubed y. And this one's going to be plus 2y over x squared. Now, my only question is, I have to see if that... This is probably like the hardest one. I kicked it off just to, you know, just to really up your excitement level. I decided to go that route. This is actually number 46. So you're doing the odds, but this is 46. What? I just want to see what the final answer is to see if we're good. 2.5, number 46. Okay, so this is not the final answer. I mean, we're pretty much there, but they've got it written as one full fraction. So we would just need to get a common denominator, which isn't... Oh, please. This one doesn't need anything. This one needs an x and a y squared. And this one needs an x squared and a y cubed. That's good. I'm here to give you a workout in the morning. So this all ends up -1 minus 2xy squared plus 2x squared y to the 4th all over that common denominator of x to the 4th y to the 3rd. We got 2x squared y to the 4th, got it, minus 2xy squared, got it, minus 1 all over x to the 4th y cubed. It is very cruel. Very cruel. But let's talk about some, in that one there's really, that's prettier than what it would have been had we gone through with the other way. Thank you. But like, let's look at this next example.
I don't know. Where was
You know, room, get out a separate sheet of paper. Or do you want to, let's just jump down to the bottom then. Okay. So, we're going to derive the first derivative. This part's no big deal. 2y prime equals 4. Get y prime all by itself. Y prime equals 4 divided by 2y, which is 2 over y. Isn't that much nicer?
Yeah.
Okay. So that's what we're going to use to come up with the second derivative. Now, do you want to do the quotient rule, or do you want to rewrite that as 2y to the negative first, maybe? I think so, too. So y double prime is going to be, bring this out in front, -2 y to the negative second times y prime. And we're going to replace y prime, because we can't have the second derivative in terms of y prime. We're replacing y prime with what? 2y to the negative first. And so this all just ends up being -4 y to the negative third, which is -4 over y cubed. That one was so much easier, right? That's more of the same on the back, isn't it? Oh, it's just evaluating, writing equations. This example here, I would say this. If it's at all possible, when you want to like jump, and we've said this from the get-go on implicit differentiation, if you can get y all by itself from the start, it's going to make your life easier. So for example, on this one, if I were to add, well, I guess it doesn't really matter, add this y over, keep the negative xy, and add y over to the left, and then keep the x on the right and subtract that 1 over to the right, and then factor out a y. I'm going to just do 1 minus x instead of negative x plus 1. And then divide by 1 minus x. What did I do wrong? I didn't take any derivative yet. I was just rearranging the original. Negative x plus 1. Because that simplifies to -1. Right, the second derivative is 0. But that's not right. I don't think it is. Let me see. That was number 48. Oh, it is 0. Y prime is 0, y double prime is 0. See how much easier that was than doing the products and all that good stuff? So much so I was suspicious. So on the back, obviously we're not going to do any more, but when you're writing the equation of the tangent line, write the equation of the tangent line to the graph at the given point. That's not a second derivative anymore. That's a first derivative, right? You just need the slope. Alright, here's what, I'm going to change your homework briefly. This is going to bump your quiz to Friday.
So I won't have to see.
No, you'll have to make it up. We are going to do numbers 45 to 51 only. 45 to 51 odds. And then tomorrow night's homework, when we get to the next couple examples, will be 53 to 57 odds. I ended up doing what?
You ended up like giving us way more.
I might.
Oh, please don't.
3 problems for tomorrow night would be a little, but they're long.
I'm expecting. I think 3 problems is plenty.
I know you do. Alright, so that's good.
If a problem takes me more than like 10 minutes.
Or should we just do...
No.
Yeah, go ahead. I was just going to make it better for you, but go ahead. Run away.
Are we learning anything new on Thursday?
No. We're going to review.
Could I take the quiz?